Hello students, welcome to the class. So as I said in the previous class, we have done with the concept of structure of atom, and we have discussed regarding all the questions which come under all the concepts in structure of atom, right? So in this class, we are going to start with the next topic, that is classification of the elements and periodicity in the properties. Yeah. Okay. Need for the classification for elements. Why there was requirement for classification of elements? See, as soon as we get things in a large number, there need to be certain systematic arrangement, right? Simple example, if you get a dozen of different types of books from the market, what you'll do, you'll try to place them somewhere, say on the table in your study room. When you're trying to place them on the table, you don't throw it here and there, you just try to arrange them. First thing, what you'll try to do, why you try to arrange them? In order to have systematic view, disciplined view in your study room, right? Now the question is how to arrange. Either you will place the bigger books at the bottom and then the smaller books above them one by one in the descending order of the size, or you will place them in a vertical columns, right? Or you will differentiate them in the form of concepts like language books are placed one side and course books are placed on the other side. So this is all what you do. Why you do those things? So that uh, the what you say, when you want to access a particular book, it becomes easy for you. Same thing when the elements were discovered. See, elements, we know matter is based on chemical classification. Matter is classified into two types, pure substances and mixtures. Under pure substances, we have these elements and compounds, right? So these elements, today we know that there are 118 elements, but those days when there was a need for classification, there were not so many elements. Hardly 30 to 40 elements were discovered. But still, studying individual element, looking at the properties into those elements, and then finding out what type of compounds that element is going to form, all these were becoming a very difficult task. They were becoming very difficult task. Therefore, they thought, let us classify these elements. Let us classify the elements. So they came up with the classification. So what is the need for the classification, periodic classification of the elements? All existing matter in our surroundings is made up of basic units, and those are known as elements. How do we define elements? They are the pure substances. They are the pure substances made up of only one kind of atoms. They are made up of only one kind of atoms, or you can say similar kind of atoms. Okay, so they were known as elements. Initially in 1800, only 31 chemical elements were discovered. After some advancement in the technology in 1865, about 63 more elements were discovered. So see, hardly there were in 1865, hardly there were 63 elements. This created the new need for the periodic classification of the elements. Presently, there are 118 elements known to us. Out of these 118 chemical elements, some elements are man-made and we call them as synthetic elements. We call them as synthetic elements. Okay. We all know that there are 118 elements present in our periodic table. Today we see the periodic table. Out of these 118 elements, 94 elements are natural elements. They are found in the nature in the form of minerals or ores. 24 elements are synthetic elements. In the year 1800, only 30 were known. With the discovery of more and more elements around 1865, around 63 elements were known. So with the discovery of more and more elements, remembering the elements and their properties was what? It was becoming a burden. So it was burdensome for the scientists. So they started gathering information about the elements and categorizing them. So when they started categorizing, I don't say that everybody started putting them in the form of table only. There were categories made by different scientists in different way. So that categorization of elements, when it was done in a tabular form, according to their properties, it became very popular. So the tabular form structure in which various elements are arranged according to their properties is known as periodic table. We'll see why this term periodic came. Okay. So first one. So periodic table means what? In general, in simple forms, we can say it is arrangement. It is arrangement of elements with similar properties. So I can say periodic table. So here I can say in easy form, periodic table is what? I can say it as arrangement of elements with similar properties placed together. Yes. So the periodic table evolved largely as the result of experimental observations. With the experimental observations, periodic table evolved. So now let us move to the earlier attempts which were made to classify the elements. The first attempt was being made by see, there were many attempts made. Those which were very significant were taken into consideration. Dobereiner's law of triads. What does Dobereiner's law of triads says? In 1829, Dobereiner arranged certain elements. He arranged certain elements with the similar properties in a group of 3. Now see, when we consider the early attempts, yes, here when I say earlier attempts to classify elements, yes, earlier attempts, when we look at the earlier attempts to classify the elements, the scientists considered atomic mass as the fundamental property. They considered atomic mass as the fundamental property of the element, and considering this point, they gave the law. They considering the atomic mass as the fundamental property, they proposed the law. So he arranged certain elements with similar properties in a group of 3. So when he made groups of 3, that group he called it as triad. So tri stands for 3. So group of 3 stands for triad. In such a way that the atomic mass of the middle element was nearly the same as the average atomic masses of first and third elements. And he stated the law. The law states that when elements are arranged in the increasing order of their atomic masses, the average of the atomic masses of first and last element is nearly equal to the atomic mass of the middle element. So this is the law which was given by Dobereiner. So what does Dobereiner's law of triad says? Let us try to understand. Triad. What does it say? What he made a group of 3 elements. That too how? That the characteristic of this group was in such a way that they are written in increasing order of atomic masses. So he took a group of 3 elements and he called it as triad. He called it as triad. Yes. The first triad what he had considered was, example, a triad of lithium, sodium and potassium. Lithium, sodium and potassium. Atomic mass of lithium was 7, of sodium was 23 and potassium was 39. So what does this Dobereiner's law of triad states? It states that when in a triad, so I have to start it like this. So in a triad, when elements are written in the increasing order of atomic masses, the average of what? The average of atomic masses of first and third element. So average, let us take the average. How do we take the average of atomic masses? 7 plus 39, the whole divided by 2, because 2 elements. Yes, so 39 plus 7 is 46. 46 by 2 is how much? It is 23. So when you take the average of atomic masses of first and third element, what value you got? It was nearly, not exactly all the time, nearly the atomic mass of middle element. You can see here. middle element. Can you see? So 23 is matching with this. Atomic mass of the middle element. So this was Drober-Renner's law of triads. So the first triad what he gave was, he gave three triads. The first one was lithium, sodium, potassium. The atomic masses being 7, 23, 39. So this was the first triad. The second triad what he gave was calcium, strontium, calcium, strontium and barium. So it is Ca, Sr and Ba. The atomic mass of calcium is 40. These are atomic masses of calcium is 40. Strontium is 87.5 and barium is 137. Okay, so let us see the average of atomic masses. Let us see here. So 40 plus 137 divided by 2. So it is 7, 7, 177 by 2. 2 ones are, 2 8s are 16. 1 comes. Again 2 8s are 16. 1 remains. Put a point, take 1 0. 2 5s are 10. So it comes out to what? Nearly equal to 88.5. So is it nearly equal to strontium atomic mass? Yes. So that was the atomic mass of middle element. And the third triad what he gave was, it was chlorine, bromine and iodine. Yes, atomic mass of chlorine is 35.5, bromine is 80 and this is 127. So 35.5 plus 127 divided by 2. So it comes out to 0.5 to 165.5 by 2. So 2 ones are, 2 8s are 16. Put a 0. 2 is there. Point. So it comes out around what? It comes out. Okay. So here 2 ones are 2. 2 ones are. So here 2 is there. 2 ones are 2. Put a point. 2 twos are 4. 1 remains. Point is already there. 2 5s are 10. So it comes around what? 81.25. Nearly 80. Yes. So this is what? Dauber-Reiner's law of triads. One was lithium, sodium, potassium. Yes, this was one triad. Calcium, strontium and barium was the another triad. And third one was chlorine, bromine and iodine. Chlorine, bromine and iodine. This was another triad. So this is according to Dauber-Reiner's law of triads. When elements are arranged in a triad, are arranged in the increasing order of the atomic masses, the average of the atomic mass of first and last elements is nearly equal to the atomic mass of the middle element. So what are the merits of Dauber-Reiner's law of triads? It made a look at elements in terms of groups of elements, that is 3 elements triads with similar chemical reactivity. So what does this mean? When I showed you this, these are the triads of Dauber-Reiner 1, 2, 3. What does that mean? It means that lithium, sodium, potassium, they have same chemical behavior. Calcium, strontium, barium have same chemical behavior. Chlorine, bromine, iodine, they have got same chemical behavior. So when there is similarity in the properties of three elements, combining those 3 elements and studying was becoming easy that time. Therefore, it made a look at elements in the term of group of 3 elements with similar chemical and physical properties. This eventually led to rigorous classification of elements and modern periodic table of elements as we know now it was discovered. So it was discovered later, but this was the first classification made. So this is here 7 lithium, sodium, potassium. This is how just now I have explained you. Chlorine, bromine, iodine, you will get 81.25. Calcium, strontium, barium 40, 88 and 137, 88.5. Yes, so this was triads of triad number 1, triad number 2, triad number 3 of Dauber-Reiner. Yes, limitations of Dobereiner. When he gave this law, it was not very successful. Why? The triads given by Dobereiner were helpful in grouping some elements with similar characteristics together. Yes, but he could not arrange all the elements known at that time. See, there were many few more elements known at that time. See, 35 elements were known, but he could make only 3 triads. For the remaining elements, when he tried to put them in the increasing, I'm sorry, when he tried to put them in the increasing order of the atomic masses, 3 elements, they were not obeying his law. So I can say Dobereiner could identify only 3 triads. He was not able to prepare the triads of all the known elements. He was not able to prepare the triads of all the known elements. And all the known elements could not be arranged in the form of triads. Yes, so that was the limitation of Dobereiner's law of triads. Immediately after Dobereiner's law of triads, there was one more law. There was one more law which was given. And that law was tellurics, we call it as, I'll write it here, tellurics law, screw law, or it was also called helix law. It was also called helix law. Yes, telluric screw you have seen, right? So usually tapers at a point. It suggested, so helix it was called. Yes. So what did this telluric law said? He started arranging the elements in the form of helical structure. And he said whatever elements come in a line were all having similar properties. So here these elements had similar properties. Coming here, these elements had similar properties. Yes. So this was not accepted by many because it had lot many what you say limitations. Therefore, that law is not studied very commonly. Yes, significantly you can say. Therefore, we have in Newland's law of octaves. So what does Newland's law of octaves says? John Newland proposed this law. He proposed this law. Newland's law of octaves. Okay. By stating that when the elements are arranged in the increasing order of their atomic masses, yes, when the elements are arranged in the increasing order of what? Atomic masses, every eighth element had properties similar to that of first. Every eighth element had properties similar to that of first. Yes. So Newland called it law of octaves because similar relationship exists in the musical notes also, just like the musical notes. So what he said, every eighth element had similar properties. When you go on arranging elements in the increasing order of atomic masses, yes, when you go on writing elements in the increasing order of atomic masses, every eighth element had similar properties. Every eighth element had got similar properties. So what he did, he tried to explain this example. So let us see how he tried to explain. So what he considered was lithium, yes, then so beryllium. These were the elements which were discovered: boron, carbon, nitrogen, oxygen, fluorine. So this was the first element. He went on writing atomic masses of these elements. So you can see this is 7 atomic mass, 9, 11, 12, 14, 16. Fluorine is how much? It is 19. So this is third element, fourth, fifth, sixth, seventh. Now when he was supposed to write eighth element with atomic mass 23, that is sodium, he found that sodium was having similar, this sodium, it was having similar properties with lithium. Therefore, he wrote sodium below lithium. So he wrote lithium here, sodium here. So atomic number 23. Again, he went on writing magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. Then when he was supposed to write potassium, he got to know that potassium was having similar properties here. So you can see here the atomic masses are in the increasing order. Atomic masses are in the increasing order. Can you see here? 32. This is 35.5. Potassium is 39 and calcium is 40. So understanding what I'm trying to say. So he went on writing elements in the increasing order of the atomic masses. He found that every eighth element, so Na had to be here, he wrote it below lithium because it was showing similar property as that of first. Magnesium, if this is eighth element, this is first element. Correct? If this is eighth element, this is first element. You can see here. If I call this as 1, 2, 3, 4, 5, 6, 7, 8, this becomes eighth. If I call this as 1, this becomes 8. 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 If you call this as 1, this becomes 8. Similarly, if you call this as 1, this becomes 8. Understanding? So he said every eighth element, so only the term octa comes, 8, had similar properties to that of the first. Every eighth element had got similar properties to that of the first. Yes. So this was, with this law, he had introduced a beautiful term. He had introduced a beautiful term, that is periodicity. Periodicity. He had introduced this term. What does periodicity means? What Newland said, when you write the elements in the increasing order of atomic masses, every eighth element is showing repetition in the properties, right? It is showing repetition, like how lithium behaves chemically, sodium was found behaving chemically. How lithium and sodium behave chemically, potassium was found showing same properties. So these were showing similar properties. These were showing similar properties. Understanding? So how boron behaved chemically, aluminum was behaving chemically. So when he wrote every eighth element showed similar properties with the first one. So there was what? There was repetition. Repetition in what? Repetition in the properties of the elements. And that repetition in the properties of elements is termed as periodicity. So there is repetition in the properties, and that is termed as what? Periodicity. So it was it was Newland who for the first time introduced the beautiful term, that is periodicity. Periodicity. Yes. You can see here lithium, boron, carbon, nitrogen, oxygen, fluorine. You can see atomic masses. So these three were showing similarity. So the question may be asked, which prop elements were having similarities in both Dauber-Reiner's triad as well as Newland's law? Yes, lithium, sodium, potassium is there in Dauber-Reiner's triad also, and lithium, sodium, potassium are showing similar properties in Newland's law of octaves also. Yes, so this was Newland's law of octaves. Then what is the limitation? What are the merits of Newland's law first? We're rather going to limitations first. I'm sorry. Rather going to limitations first, let us try to understand what are the merits of Newland's law of octaves. Correct? What were the advantages? This classification, it worked very well for the lighter elements. Up to what? Up to calcium. Yes, it worked very well up to calcium. Just now you saw the table. It worked very well till calcium. Yes. Second point. This property, this classification gave us the relation between what? It gave us the relation between properties of elements and their atomic masses. Atomic masses. So he said when you write atomic masses in the increasing order, every eighth element had similar properties. So it gave us a relation between properties of the elements and their atomic masses. Third point, it was shown by this classification for the first time that there exists what? Very important point. There exists periodicity. There exists periodicity in the properties of the elements. Periodicity in the properties of the elements. Correct? Periodicity, repetition in the properties of the elements. So these were the merits. It was very well, it worked up to, for lighter elements up to calcium. Properties of the elements and atomic masses, there was a relation found between properties of the elements and masses. And very important, it showed that there exists periodicity. What does periodicity mean? There exists repetition in the properties of the elements. So there exists repetition in the properties of the elements. But the point what Newland said is the repetition is exactly mentioned. That is, it is exactly after seventh element. Why I'm saying this? Because he said every eighth element showed similar property. So exactly after seventh element, there is repetition. He mentioned a constraint. He mentioned a, what you can say, period of 7 elements. He mentioned a period of 7 elements. So that became the limitation, you can say, students. That became the limitation. We'll see how it became the limitation. This classification, it was successful only up to element class calcium. After that, every eighth element did not possess the same properties as the element above it in the same group. So every eighth element did not possess the same properties. That means up to calcium there was periodicity, there was repetition. But after calcium, the repetition, the periodicity in the properties of the elements was not found. That means this law was not obeyed after calcium. Right? Next, at the time of this law, the noble gases were unknown. The noble gases were not discovered. They were not discovered when Newland's law was given. When noble gases were discovered, and all the noble gases were not discovered. The noble gases which were discovered were neon, Ne, yes, argon, Ar, argon. So these were mainly discovered noble gases. So when noble gases were discovered, neon was placed between fluorine and sodium. It was placed between fluorine and sodium, and argon was between chlorine and potassium. Yes. So it becomes ninth element and not the eighth element which had similar properties. You can see here. You can see here. Between fluorine and sodium, what he did, he placed neon. He placed neon here. And between chlorine and potassium, he placed argon here. So when he placed this, these became eighth elements, and this became what? This became ninth element. Similarly, when this became eighth element, this became ninth element. But his law says every eighth element. Understanding? His law says every eighth element. Therefore, that was another drawback. Yes. So when noble gas elements were discovered at later stage, their inclusion in the table disturbed the entire arrangement. It disturbed the entire arrangement. Yes. It disturbed the entire arrangement. So these were the limitations of Newland's law of octaves. Newland's law of octaves. So to solve the Newland's law of octaves, there came next scientist, and that was Mendeleev's periodic law. Mendeleev's periodic law, which gave Mendeleev's periodic table. So in 1869, after the rejection of Newland's law of octaves, Mendeleev periodic table came into the picture. In Mendeleev's periodic table, elements were arranged on the basis of fundamental property, that is atomic mass, and chemical properties. During Mendeleev's work, only 63 elements were known. After studying the properties of every element, Mendeleev found that the properties of the elements were related to the atomic masses in a periodic way. He arranged the elements such that elements with similar properties fell into same vertical columns of the periodic table. So what I say here is Mendeleev's periodic table, the first significant classification was given by Mendeleev. So only when you look at Dauberreiner's law, we call it as law of triad. Newland's, we call it as law of octaves. They just gave the classification of the elements. They did not put the elements, classified the elements in the form of table. Yes, therefore, the first significant classification, it was given by Mendeleev. Why I say significant classification was being given by Mendeleev? Because it is in the form of periodic table. And that periodic table is known as Mendeleev's periodic table. So it was based on Mendeleev's periodic law. So what does Mendeleev's periodic law says? So Mendeleev's periodic law says that The physical and chemical properties of the elements are periodic functions of their atomic masses. Mendeleev, he was known for many years, but lot much work was not done by Mendeleev. Actually, the work was done by Newland only, because one of the merits of Newland's law says that he introduced the term periodicity. He said after seventh element, every eighth element showed repetition, and that is repetition in the properties. That is periodicity. And the demerit was he put a constraint that every eighth element shows the properties. Every eighth element showed the properties, repetition in the properties. So what Mendeleev did, he just modified Newland's law. He said, yes, of course, as Newland says, there is repetition. There is repetition in the properties. Repetition, or you say there is periodicity in the properties. Periodicity in the properties of the elements. That too when? Periodicity in the properties of the elements when elements are arranged in the increasing order of atomic masses. Yes, there is repetition. See, what Newland said, the same thing is said by Mendeleev. But he said the repetition is not exactly at the eighth element. The repetition might be anywhere. The repetition might be exactly after two elements. The repetition might be after eight elements. The repetition again might be after eight elements. Understanding? So when you go on writing, so what Mendeleev's law says, the physical and chemical properties of elements are periodic functions. Periodic functions of their atomic masses. What does this means? It means that when elements are arranged in the increasing order of atomic masses, there is repetition in the properties of the elements at regular intervals. At regular intervals, not exactly eighth element, at regular intervals of what? At regular intervals of atomic masses. At regular intervals of atomic masses. So Mendel's periodic table, what he said, according to Mendel's periodic law, when you arrange the elements in the increasing order of the atomic masses, the repetition in the properties of the elements is seen. The repetition in the physical and chemical properties of the elements is seen at regular intervals of atomic masses. Not exactly after 7. At every eighth element, there is no repetition. After regular intervals, there is repetition in the properties. So this was called as Mendeleev's periodic law. The physical and chemical properties of the elements are periodic functions of their atomic masses. Is that clear? So Mendeleev, what he did, it was the first significant classification because he arranged the elements known at that time in the order of increasing atomic masses, and this arrangement was called periodic table. Elements with similar characteristics, similar properties, they were placed in vertical rows, and he called those vertical rows as groups. And even the horizontal columns were there, they were called as periods. Vertical columns and horizontal rows, he called them as groups and periods. Yes, so here is the description what actually Mendeleev did in his periodic table. In the periodic table, the elements are arranged in the vertical rows called groups and horizontal rows known as periods. There are 9 groups. They were indicated by Roman numerals from 1 to 8, and last group was called 0. Yes, so he named them 1, 2 with the Roman numerals, 3, 4, 5, 6, 7, 8, and last group was not 9, it was called 0. So there were totally how many groups? What are groups? They were vertical rows. He called them as groups. There were 9 vertical rows in Mendeleev's periodic table. Yes, and that it was numbered with Roman numerals 1 to 8 and 0. Group 8 consists of what? Group 8 consists of 9 elements which are arranged in 3 triads. Group 8 consists of 9 elements which are arranged in 3 triads. The zero group contains elements belonging to inert gases or noble gases. Inert gases or noble gases. Yes. And elements present here, which were elements present, they were inert gases or noble gases, and these elements have zero valency. They had zero valency. Their valency was zero. Their valency was zero. Understanding? So these were the elements. This was the arrangement of Mendeleev's periodic table. There are 7 periods. They were numbered from 1 to 7, or you can say horizontal rows. There were 9 vertical rows called groups, and so 9 vertical rows, or you can say columns, and they were called groups, numbered with Roman numerals 1 to 8 and 0. Yes, and there were 7 horizontal rows, and he called them as periods. He called them as periods. Yes, they were numbered from 1 to 7. 1 to 7 in the Mendeleev's periodic table. Yes, in the Mendeleev's periodic table. Okay. What are the characteristics? Yes, we discussed vertical columns in the periodic table and horizontal rows in the periodic table were named as groups and periods respectively. It consisted of 7 horizontal rows or periods and is numbered between 1 to 7. There is regular gradation in the properties of the elements in periods from left to right. Periods were named with 1 to 7, and there were regular gradation in the properties. The periodic table was composed of 8 vertical columns plus 1, that is was named as 0. So 1 to 8, they were numbered, or Roman numbers 1 to 8 and plus 1. Correct? Okay. If the element is similar but not much, to distinguish between them, it is placed below and slightly away from it. Thus, each column will have 2 subcolumns, A and B. So, elements will show more similarity in same subcolumns. The groups from 1 to 7 are meant for normal elements. Group 8 is for transition elements. Groups from 1 to 7 have been divided into 2 subgroups, while group 8 is meant for 3 elements. 3 subgroups I have told. Periods from 4th to 7th have been divided into 2 series, first series and second series. So this was the characteristics. 2 general formulae, one for oxides and second for hydrides, have been given for the elements of each group in the periodic table. See what all he did. For oxides, it was R2O. For hydrides, it was RH in the first group. So for R2O was for oxides, RH for hydrides of the elements of first group. Yes, using the given general formulae, the formula of oxides and hydrides can be written for the elements of each group. For example, hydrogen, sodium, potassium, etc. belong to first group. So formula of oxides for those elements was written as R2O. Accordingly, they form H2O, Na2O, K2O, etc. Yes. Importance of Mendeleev's periodic table. What were the achievements? This made the study of elements quite systematic in the sense that if properties of one of the elements in a particular group are known, those of the others can be predicted. So if you know properties of one of the elements in a particular group, then the properties of remaining elements in the same group can be predicted. This helped to a greater extent in the discovery of the elements at later stage. See, what was the biggest achievement of Mendeleev's periodic table is that first one, it had simplified and systematic, you can say. So simplified and systematized study of elements was possible. Study of elements, and not only of elements, their compounds was also made. So only oxides and hydrides you can see there. So it was simplified and systematized. Even it helped in predicting the discovery of new elements. It helped in predicting the discovery of new elements on what basis? on the basis of the blank spaces in his periodic table. See, what Mendeleev did was, when he was giving the periodic table, you can see here, yes, this is the periodic table. What Mendeleev did was, he left some blank spaces. Yes, he said those elements were not discovered. Hardly 63 elements were discovered. Mendeleev left some blank spaces and he said there will be, in the future, the elements will be discovered and they have to be placed below that particular only. Below aluminium, he had placed here, he had left the gap. Below silicon, he had left this gap. He had left this gap. This is after discovery what it is shown. So he had left the gaps below aluminium, below silicon, he had left the gaps and he predicted the discovery of those elements. He predicted the discovery. That means in future, the elements will be discovered and they will have the properties as that of aluminium. So he called those gaps, he named those gaps as, he said the elements will be discovered below aluminium. What he named is, he named it as Eka aluminium. And below silicon, he named it as Eka silicon. Eka stands for one of the same kind. He said, whatever elements, whatever gaps I have left, vacant spaces I have left, whatever elements come there, they will have similar properties to that of aluminium. Therefore, he called Eka aluminium. And below silicon, whatever elements come below silicon, they will have similar properties to that of silicon. See, this was the, what you can say, the very extreme level. He predicted the properties of the discovery of new elements by leaving the blank spaces. Next, Mendeleev predicted, not only he said the elements will be discovered, he even predicted the properties of those missing elements also. So he predicted the properties of the elements which were discovered later. How he predicted the properties of the elements which were discovered later? That only, of Eka aluminum and Eka silicon, by looking at the properties of elements placed above. So he has left a gap below aluminium and he called it as Eka aluminium. He has left a gap below silicon and he called it as Eka silicon. So how he predicted the properties of these two elements also. How? Based on the properties of aluminium. Based on the properties of aluminium, he predicted the properties of the elements which he thought to be discovered later. Yes. So he predicted the properties of the elements from the known properties of the other elements in the same group. Example, Eka aluminium and Eka silicon were later they were given name. Eka aluminium was later, when it was discovered, he gave it as Eka aluminium. Later, when it was discovered, it was given name as gallium. Eka silicon, when it was discovered, it was called germanium. I just showed you in his periodic table. Yes, they were given names as gallium and germanium, which were not discovered at the time of Mendeleev. Later on, it was found that the properties which were predicted by Mendeleev, about Eka aluminium and Eka silicon, they were same as that of, they were same. Yes, I'll just tell you the properties also. For example, let me say Eka aluminium, which was later called as gallium, and Eka silicon, which was later called as germanium. Okay, atomic mass. Mendeleev predicted the atomic mass of Eka aluminium to be 68. And when gallium was discovered, the scientists, that time Mendeleev was also not alive. When gallium was discovered, its atomic mass was found to be 70, almost same. He even predicted the atomic mass of silicon. He said it might be around 72. And when it was discovered, Eka silicon, that is in the name of germanium, it was found to be 72.6. Yes, not only atomic mass, density in grams per cc, he said the density of the element to be discovered, that is Eka aluminum, would be 5.9, and it is found that the density of gallium is 5.94. Even the density of silicon, he said, predicted, it was not found because element only did not existed. He predicted through his theoretical basis. He said it might be around 5.5, and germanium, it was 5.36. Yes, he predicted the melting point also in Kelvin. I'll tell in Kelvin. He said the melting point of Eka aluminium will be low. If it is discovered, it will be low. And the melting point of gallium after discovery was 30.2. It is low only. For silicon, he said the melting point will be high. And melting point of Eka silicon, okay. And when it was discovered, germanium, it was 1231 Kelvin. Apart from that, he said the oxide formation and chloride formation about the compounds also. Eka aluminium, when it combines, that is this element, later when it will be discovered, if it combines with oxygen, it will form an oxide of the type E2O3. So gallium, when it was discovered, they found that gallium was forming the oxide of type G2O3. Similarly, he said silicon will form Eka silicon, the element which would be later formed would have the oxide of type E2EO2, and germanium forms oxide of type EO2. Even chloride, he said if it combines Eka aluminum element when later discovered, if it combines with chlorine, it will form chloride of type ECl3. Later, gallium, when it was made to combine with chlorine, they found that gallium forms chloride of type GaCl3. Similarly, Eka silicon, he said it forms a chloride of type ECl4. When germanium was treated with chlorine and found what type of chloride it forms, it was forming chloride of type GeCl4c. Same it is. So look at the knowledge of Mendeleev. He just not discovered the classification of the elements. He did not just put the elements making it simplified and systematic, but he predicted the discovery of the elements. Along with the prediction of the discovery of the elements, he called them as Eka aluminium and Eka silicon, leaving blank spaces below aluminium and below silicon. He even predicted the properties of the elements. He predicted the properties of the elements. Yes, these were the predicted properties of the elements. Yes, so these were atomic weights of the elements were corrected. Another achievement of Mendeleev was atomic weights of the elements were corrected. How did he correct? How did he correct the atomic weights of the elements? See, what he did was atomic weight of beryllium was calculated to be 3 into 4.5, that is 13.5, by considering its valency 3 beryllium. It was correctly calculated considering its valency. He considered the valency 2. That means beryllium can combine with the two other elements only. It can give its 2 electrons only. So 2 into 4.9, it came out to 9. To 4.5, it came out to 9. See, that was the correct atomic mass of beryllium. So even he corrected the atomic masses of the elements. How intelligent fellow he was. He corrected the atomic masses of the elements. So these were all the achievements of, or you can say merits of Mendeleev's periodic table. Yes. So it had simplified and systematic study of elements and their compounds, helped in predicting the discovery of new elements. Even Mendeleev predicted the properties of the new elements which had to be discovered later, looking at the properties which were existed before. Yes, and even the atomic weights of the elements were, some of the elements were corrected. Yes, in some cases, elements with, yes, okay. So this is about Mendeleev's periodic table. Then why with so many useful things, Mendeleev's periodic table was not accepted? There were still questions regarding. So what was the defects? What were the demerits in Mendeleev's periodic table? The first demerit, yes, you can see here, hydrogen has been placed in group 1A. The first demerit of Mendeleev's periodic table, I'll discuss first here and then we'll read out. Yes, the first demerit was regarding position of hydrogen. Position of hydrogen. Yes, hydrogen resembles like hydrogen element. It shows a similar properties like lithium, sodium and all, potassium. These were called alkali metals because when the oxides of these metals were put in water, they were forming basic, some of the oxides were forming basic solutions. Therefore alkali stands for basic. And similarly, hydrogen was resembling the properties same like fluorine, chlorine and what? Yes. So it was showing similar properties like hydrogen, lithium, sodium, potassium. That was hydrogen with electrons number one electron. It was losing electrons and forming H plus ion. Same like alkali metals, they form M plus ion. And like fluorine, chlorine also it was showing similar properties. That is, hydrogen was gaining one electron and even forming H minus, which was called hydride. Same like our fluorine, chlorine. These were also forming, by gaining one electron, they were forming chlorides. So hydrogen resembles both alkali metals of group 1A according to Mendeleev's periodic table and halogens of group 7A in the properties. So Mendeleev could not decide where to place it. So this was first drawback. Position of hydrogen was not fixed. Second very important drawback was position of isotopes was not fixed. So we know already now what are isotopes. They have same atomic number and different mass number, correct? How Mendeleev's periodic table is there? In the increasing order of atomic masses. So when you write elements in the increasing order of atomic masses, how isotopes, if I say isotopes of hydrogen are 3, 1H1, 1H2, 1H3. Yes, these should have, in the Mendeleev's periodic table, all these three should have different blocks. Yes or no? Atomic mass in the increasing order of atomic masses, because see, lithium had atomic mass 3, beryllium had atomic mass 4, 9, lithium 7. So he placed them separately, right? Different blocks. So when isotopes are also having different atomic masses, they had to be placed separately, 1H2, 1H3. But what he did, he placed all of them in one block only. When scientists criticized this, he was unable to explain. As atomic weights of isotopes differ, they should have been placed in a different positions in the Mendeleev's periodic table. But there were no such positions for the isotopes in the Mendeleev's periodic table. So this was one more limitation. This was one more limitation. Third point was anomalous pairs of elements. What he did was, he separated the elements, let me say here, he separated the elements with similar properties, that is, he placed them far, and he placed elements with different properties together. Elements with different properties together. So dissimilar, I can say dissimilar elements were placed together. Dissimilar elements were placed together and similar elements were separated. Similar elements were separated. Now how to explain this? Yes. So the length of the periodic periods are determined by the arrangement of the electrons in different orbits. The period ends on the completion of last orbit. So different periods, they contain different elements. So now out of two elements, which every long period adds to group, one resembles similar properties. So let us try to understand this. These similar elements were placed together and similar elements were placed. Similar elements mean what? Properties. Dissimilar elements means properties of the elements were different. They were placed together. And similar elements means what? The elements with similar properties were separated. So that was called as anomalous pair of elements. There were some pair of elements which did not follow the increasing order of the atom. So example here, platinum and arganium, which have similar properties, they were placed in group 7, group 8 and group 18 separately. So they were having similar properties, but they were separated. Yes, there were some elements which were having different properties and they were placed together. So this was anomalous pairing. One more point in this, there were some pair of elements which did not follow the increasing order of the atomic weights. For example, argon and cobalt, they were placed before potassium and nickel respectively in the periodic table. These two are having higher atomic masses, but they were placed before this. So these should be placed first. Potassium should come first, nickel should come first because they were having lower atomic masses. So according to Mendeleev, atomic masses are written in increasing order. So first potassium and nickel should come, then argon and cobalt should come. But in his periodic table, these are placed before potassium and nickel. Yes. Then there were some pair of elements which did not follow the increasing order, say Ar. Yes, so these were the cases. Next is like elements were placed in different groups and unlike elements were placed together. Like elements were placed in different groups and unlike elements were placed together. So these were the demons. Let us see what are being given here. Okay, hydrogen has been placed in group 1A along with alkali metals, but it also resembles halogens in group 7A in many properties. Thus, its position in the Mendeleev's periodic table is controversial. First one, so position of hydrogen was not fixed. Second point, although the elements in the Mendeleev's periodic table have been arranged in the order of increasing atomic masses, but in some cases, the elements with higher atomic mass precedes the element with lower atomic mass. Just now we have seen argon and cobalt, they were placed before potassium and nickel. We know that isotopes of the elements, see, position of the isotopes was not fixed. Isotopes of an element have different atomic masses but same atomic number. Since periodic table has been framed on the basis of increasing atomic masses of the elements, different positions must have been allotted to all the isotopes of the particular element. This I told only for hydrogen. There are so many isotopes for different elements, right? So that was not explained. That was not given. According to Mendeleev, the elements placed in the same group must resemble in their properties. Same should show similarity. But there was not similarity among the elements in two subgroups of the particular group. See, each group had got a subgroup. I'll show Mendeleev's periodic table. There should be similarity, but in some cases there was no similarity. In some cases, elements with similar properties have been placed in different groups. Elements with similar properties were being placed in similar groups, different groups. Lanthanoids and actinoids. Yes, last elements in from 58 say to 71, actinoids from 90 to 103. These are the elements called lanthanides and actinoids. They are called so because lanthanoids start after lanthanum element, so they were called lanthanides. There are around 14 elements. Actinoids start after actinum element, therefore they are called actinoids, and they are also 14 elements. They are together called F block elements, today we know. But during Mendeleev's time, lanthanoids and actinoids were placed in two separate rows at the bottom of the periodic table without assigning proper reason. Today also in the periodic table, they are placed at the bottom. And we know we have the reason now why they are placed in a separate rows. But when Mendeleev did that, he did not have proper reason of why he did so, why he placed lanthanides and actinides in a separate rows. Now we know the reason is because there is similarity in horizontal lanthanides and actinides. But that time Mendeleev could not give the proper reason. So you can see here, this is Mendeleev's periodic table. Mendeleev's periodic table. Yes. So Mendeleev's periodic table, below aluminium, he left the gap. He said it will be discovered, and later after discovery, it was called gallium. Below silicon, it was called germanium. Yes, these were called zero group elements: helium, neon, argon, krypton, xenon. And even he predicted the oxides. You can see here R2O oxide, RO, R2O3, means these particular elements will form those oxides. These particular elements will form those oxides. He placed some of the elements which different properties together, and he placed different elements. He different elements together, and he separated the properties with similar he separated the elements. Yes. Next, in some cases, elements with similar properties have been placed in different groups. Okay, we have discussed this. No proper explanation has been offered for the fact that why the elements placed in the group shows resemblance in the properties. So what he did, he placed the elements in the groups. So this was a group, correct? This was a group. This was a group. This was a group. Yes, vertical columns were called groups. There were these many groups. He said there is similarities in the properties, but he did not have any explanation as to why there was similarity in the properties of those groups. Why there was similarities in the properties. Yes, so no proper explanation has been offered for the fact that why elements placed in a group show resemblance in the properties. Resemblance in the properties. So you can see here, he even said R2O oxides, and this is of hydrides. So if you take example here, R2O3 and RH3, oxide of this. So if boron is combining with oxygen, it will form oxide of type B2O3. If aluminium is combining with oxygen, it will form oxide of type Al2O3, and he left this gap. Even this gap was also left. Eka boron, it was called Eka boron. This was called Eka aluminium. This was called Eka silicon. Yes. So he said they will also form oxides of type so and so by looking at above elements. Even hydrides, if you consider, for example, let us say this hydride. Beryllium, magnesium combines with hydrogen and it forms hydride of type MgH2. Yes, so these are the oxides and hydrides of different groups. Different groups. Yes, so this is Mendeleev's periodic table. Mendeleev's periodic table. Right? Okay. So let us stop with Mendeleev's periodic table. We have discussed till three periodic classifications: Dobereiner, Tellurich's law, then Newland's law, merits and demerits, Mendeleev's periodic law, all the characteristics of Mendeleev's periodic table, then then the merits of Mendeleev's periodic table, achievements you can say, and the demerits of Mendeleev's periodic table. In the next video, we'll start with modern periodic table. Modern periodic law. This law, due to these limitations, what all we discussed now, was not successful. Why these all laws were not successful, we'll understand it in the next law. What drastic takeover was being done. Yes. So for now, I hope try to make the oxides of all these compounds or the hydrides of all these compounds and just verify them, because the questions might be asked. Group 5 element belongs to group 5. What type of oxide it can form? Or element belongs to group 7 of Mendeleev's periodic table. What type of hydride it can form? So these are the expected questions. Please work on that. For now, thank you.